All right, so without further ado, let's go ahead and get started. And my name is Eugene Chuvyrov. I work for Microsoft. I'm on the commercial software engineering team. And it's sort of like it's a new term or a new team for Microsoft where we partner with companies or ISVs such as Consensus in the blockchain space to enable them in our cloud. And so my team specifically has been tasked with working with startups, a lot of the names that you know, not just obviously in the blockchain space, but also in media, machine learning, DevOps spaces, and actually basically make sure that they're enabled in our cloud to the fullest. All right, and as part of this work, I had a chance to work with several blockchain ISVs, which is what my presentation today is about. So here's a brief agenda here. So I guess I was just thinking like at 5 o'clock, I just want to make sure I kind of keep you guys awake and maybe sort of make it worth your time. And so I guess the one way I came up with how I can do this is to actually try to make this an engaging or interactive session. So basically, I wanted to start off with a philosophical discussion about enterprise blockchain and sort of we'll solicit the audience input. So we'll kick off with this, and then we'll recap blockchain fundamentals or kind of when blockchain or when we think it makes sense. And then I think that my biggest goal here is to just tell you what we, Microsoft, do with blockchain in Azure today and what our plans are for tomorrow. All right, so here's the philosophical discussion portion. And I was kind of like scanning materials for the session, and as you can see, sort of I just clipped the tweet from Alex Rampel. I don't know if you guys know him, but he works for A16Z. He's a venture capitalist there. And so it's worth actually kind of reading verbatim. I hope you guys don't mind. So basically saying, I'd argue that enterprise blockchain is an oxymoron. It's the new buzzword. Centralized database makes more sense for most companies. So consequently, enterprise blockchain people, at least the one I've met, are typically not tech people. So now that I set the bar pretty low for myself here, I have nowhere to go but up. And so I guess as a final tweet, he just says, I met a large bank CEO who told me I want blockchain but no Bitcoin, and I want the blockchain private on my own data center. So here's obviously a very prominent venture capital. He actually works in the financial space. I have a friend who used to work for him for his company, previous company, I think it's called TrialPay. And so obviously, if you guys listen to podcasts, A16Z podcast, he's a frequent guest speaker there. Very valuable. So here's his opinion about enterprise blockchain. And yet here we are today speaking exactly about this. So just for the interactive portion, I just wanted to see what your guys' opinions are, and just feel free to just raise your hand or just say it out loud. I mean, what do you think? Are you familiar with basically the blockchain in general? If you are, do you think enterprise blockchain makes sense? So anybody, any volunteers here? It's 5 p.m.
That's kind of why I'm here.
You kind of here to learn about it? Go ahead.
Well, you know, it's a big buzzword right now, blockchain. And I understand the concept when it refers to currency, but then I sort of think, well,
Right.
does that apply to an enterprise operation?
Right, if you think blockchain is a buzzword, enterprise blockchain is 2x that. So, go ahead.
I think it seems like there could be a disaster. In the morning session, they talked about, the first part is a little bit like GitHub. You have a linked list of hashes that verify data. You don't throw things away. The immutability, the security. But then you get into this thing where when you want to combine everything and everybody shares it, you're going to have almost like event storms. Where things get rejected and they start bouncing back and forth. And you see that in user interfaces. If you use Angular and all these other things, that you've got events going back and forth. You ask something to plot, it gets plotted 15 times. So to me, you've got a lot of work to do to have a system that's efficient, that you have a very high hurdle to get everybody to talk the same language.
Right, and I think actually even the bigger hurdle right now is just sort of the whole concept of enterprise blockchain in a sense. And so hopefully, I think my value would be here just to communicate what we mean by that or what we think we mean by that, because there's the blockchain, there's obviously public blockchain, but there's also this what we view it as evolution of sorts. And just sort of like, I think it's pretty important to kind of level set like the general Microsoft approach to blockchain. And sort of we try to play, I heard it from one of the developers, we try to play Switzerland. So we basically, we try to enable everybody on the blockchain, both the startups working in that space, the enterprises getting on that. And so in this particular case, it's just like, it's a philosophical discussion because clearly, I mean, even though, let's say, I may have an opinion, I will try not to impose it on you and just basically let you make a decision for yourself whether enterprise blockchain makes sense for you. All right? So on that note, let's just see what kind of let's just see the general arguments that people propose when they say a blockchain or enterprise blockchain specifically makes sense. So what are the disadvantages, right? The blockchain at its core is it's basically a secure, and then, so there's 4 keywords that are critical to the whole, I guess, the blockchain pieces. It's a secure, shared, distributed ledger. So let's go through each one of those, I guess, separately. So it's secure for exactly the same reason as you mentioned, the gentleman here in the front row. And so just to recap, even though Alex thinks we're not very technical, so I guess just to recap, it's secure because basically each block in its header contains the hash of the previous header's block. So in that hashing, kind of forming a linked list, make the blockchain immutable or permanent, because if you were to change the underlying data, the hash would change. It would be like a chain reaction to, so to speak, invalidating the whole blockchain. So the fact that the hashing mechanism, and it's just actually there's optimization built in there in form of the Merkle trees, which basically store transactions and then hashes of those transactions kind of bubble up to the central hash. And so those optimizations are still basically working the same principle, whereas the hashing that's stored in the header forming this linked list of transactions that are basically indestructible. So that's why it's secure. It's digitally signed and mathematically guaranteed to be authentic. And so then the second benefit is that it's shared. So it's not a centralized thing. It's shared between different entities. So you can have a copy of the blockchain, your supplier can have a copy of blockchain, your customers can have a copy of the blockchain if you so choose. And in the public blockchain, this is exactly the case, right? So if you think about like Bitcoin blockchain, obviously the granddaddy of them all, it's still a public blockchain where you can download the full ledger onto your computer. I believe it's like 120, maybe 150 gigabytes total. And you can actually look at the transactions. So it's shared. And I guess this decentralization or the shared mechanism is a huge advantage for those systems where you want to make sure that no single party actually has access or has the capability to change history. And so the third thing right there is it's distributed. So again, many copies exist. They're replicas of each other. So it goes together kind of with shared, but again, decentralization here. And then finally, it's a ledger. So it's a write once, and it's immutable. You have the history of all transactions available. And so that's kind of like in a nutshell, when you see people justifying or having a discussion between, let's say, blockchain versus a database. So those are the arguments that are being put forward. And actually, sort of, I can clearly kind of remember when I just started in that space, just when I joined Microsoft about 2 years ago. And the first question people ask when they look at this, like, okay, why can't the database do this, right? This is exactly the database. The database is faster, it's proven technologies, everything. And in many cases, database makes perfect sense. And so it's sort of like the blockchain community, and specifically kind of the customers we work with, they went back and said, okay, we think it makes sense when your use case is basically kind of fits in within its profile. You want something that's secure, shared, distributed, and basically not, you don't have a central, you don't have the need to basically centrally modify it. So before we just kind of talk about further advantages of blockchain, it's just kind of here's a partial picture of how we view blockchain evolution at Microsoft, and there's a continuation of that picture later on the slides. But basically, blockchain 1.0, it was the Bitcoin. It's a simple ledger, the recorded transactions, there was very limited ability to execute scripts. There was a scripting language, but it wasn't Turing complete, which basically means you couldn't run any arbitrary program out there. So now, today, we're in a blockchain 2.0 phase, where the smart contracts, specifically on blockchains such as Ethereum, and the, I guess, evolutions of that blockchain came about. So this introduces the logical tier. So now, in blockchain 2.0, you have Turing-complete languages that kind of run the logic on top of the blockchain. And so what does this enable us to do? This enables us to kind of have this, I guess, the lead-in into enterprise blockchain space, where we view version 1.0, we basically had public blockchains. So the types of network existed with many unknown participants. Writes could be accepted by all participants, reads by all participants, consensus by proof of work. And so consensus mechanism, if you guys don't know, it's basically consensus is an agreement of sorts what the blockchain in the end should look like. And I guess when many parties contribute transactions to the blockchain, somebody has to decide what the blockchain in the end would look like. And kind of like the election of that, or the consensus is achieved by proof of work, with many computers kind of solving those cryptographic puzzles that require a lot of computation. And that's the essence of Bitcoin. So basically, you got rewarded for if your transaction, if basically you were able to solve this cryptographic puzzle and add a block to the blockchain. So this is 1.0, right? Public. There's no argument about that. I mean, look at the Bitcoin price. I mean, some say it's speculative, obviously, but certainly there's legs behind that movement. So I don't think anybody kind of is disputing the value there in the public blockchain. So now we come to this vision, or sort of a, I guess, a point of view, so to speak, is probably a better word. Now we want to evolve the blockchain into a private and consortium space. Okay, and this is where we touch this things like enterprise blockchains in a sense. So in private, we have just one organization, centralized write permissions, reads may be public, multiple algorithms for consensus. So, and we'll go over those algorithms for consensus later on in the slides. But so in this case, you can clearly argue, well, why not just a database, right? And it's a good question. And I can tell you why not a database just a little later on, or why potential not a database. And so I guess where we really think the sweet spot is, at least in our view, for enterprise blockchains is in this consortium space. So consortium space is obviously multiple companies, probably within the same industry, such as financial services, healthcare, and we work with those guys actually very actively. They're very engaged. They're developing on top of basically blockchains 2.0. And so those consortium blockchains are characterized by known participants, rights require consensus, reads may be public, so multiple algorithms for consensus as well. So when we talk about enterprise blockchains, most likely this is going to be it. I mean, the consortium blockchains, sort of like let's think in financial space, what does it take to get JP Morgan, Bank of America, Wells Fargo to talk to each other and basically get together around the same table? Most likely today it's the conversation about consortium blockchain. So just kind of like further drive the point home in the sense like, so why would it make sense for blockchain not to be public, right? Why would it make sense for blockchain to be basically enterprise blockchain, so to speak? So I guess this argument is that decentralization, and we already kind of made it, but basically the blockchain safely distributes ledger across the entire network, does not require the middleman, the technology maintains multiple replicas. So in traditional system, again, if you think about consortium blockchains, could you put a central database and have people agree to kind of transact with each other? Well, certainly, but then somebody gets this idea that they can probably alter some transactions, execute some delete statement, or something else, and you no longer have the audit log or the track record of what's been done. So if you come together around this consortium blockchain space, then there's certain guarantees that the system already has, and that's what's attractive. All right, so here's just kind of like enumerating potential benefits, additional potential benefits of blockchain when working with enterprises. And this is based on the use case that we've seen. So eliminate intermediaries. You can basically redefine or create new business models, reducing fraud related to data integrity. As we kind of already mentioned, the data is highly secure, it's transparent. You cannot modify historical records. Increases efficiency and speed. So when basically there's multiple parties in trustless environment, enables you to solve transactions faster, reduce counterparty risk, and increase sort of revenue and savings. So those are the benefits that basically draw people to consortium or enterprise blockchains in our experience. And we see blockchain suited for all industries, actually. So here in the financial industries, you have the ability to redesign costly workflows, improve liquidity. In healthcare, and as I mentioned already, we work with the companies in those spaces. And basically, imagine that, kind of in healthcare, if you remove the third-party verifiers and enable patient record sharing freely, I mean, certainly that would reduce the costs by so much, and also probably to much better outcomes. I mean, we're still far away from this goal, but I can tell you certainly there is quite a few efforts around that. And the governments, right? We do work with government agencies to increase transparency and traceability of how money is spent, track asset registrations, and just reduce fraud. And so retail and manufacturing through basically provenance, with the ability to track the assets from the inception all the way to the store. That's huge. Results in better supply chain management, smart contract platforms, et cetera. So anyway, this is sort of just sort of like marketing information still. And hopefully you guys get the idea that I am kind of, even though initially I said we try to be Switzerland, those set of the slides kind of make the case for, hey, you know, in some cases blockchain or enterprise blockchain does make sense. All right, and then the most common scenarios that we see are trade finance, global payments, know your customer, and asset transfer. All right, so with this case being made, and whether you agree with enterprise blockchain premise or not, you know, let's just see kind of where Microsoft comes in, right? So where do we come in? What do we add to the value? What do we add, or how do we enable you with enterprise blockchain today? So this is, in blockchain 2.0, this is where we are today. So we formed strategic partnership with key startups and key companies behind the major blockchains, I guess I can say it's plural. So we released the initial blockchain as a service framework, so to speak, and I'll show the slide on that later on. And so we started doing, or we are doing the foundational work on the future of what we see as being, I guess, on the future of the infrastructure that will enable basically better blockchain solutions. So what does this all mean? Besides sort of like, okay, what is strategic partnership? I mean, this is Code Camp, right? So clearly you came to see code, and code is coming up. But here is just a recap of kind of like a smart contract concept. So the basic idea was just, let's take the traditional contract that sort of codifies certain properties there. I believe this is basically transfer of motor vehicle. So we take this paper, we basically codify as a smart contract, we'll put it on the blockchain and deploy it to nodes. And so once the contract is running onto nodes, I guess the clients, or the distributed apps, I guess we call them, through basically tools that you're familiar with, such as, I guess, AngularJS, React frameworks, they can make RESTful calls, interact with blockchain to either read or write to it if they're enabled. So kind of a logic in a traditional contract codified and deployed to nodes. And I guess it's important to note here that obviously kind of when we write this code, smart contract code, and we will write some code here and shortly, it's still basically a programming language. But the original vision, or I guess the long-term vision of this is, this contract that we see on the left, we should be able to basically put in the legal terms that are familiar to both the lawyers and maybe lay people can understand it too. So that ideally, the long-term plan is not to involve programmers like us, just because that's exactly what the smart contract terminology really is supposed to mean. All right, so here's our initial pillars of blockchain as a service. Sorry, I went too far. So let's ignore kind of like the right-hand side of the slide for a second and just focus on the core platform here. So what we did in Azure today, we enabled all those guys. So EEA stands for just the Enterprise Ethereum Alliance. So there's the blockchain called Quorum. We'll look at this shortly. So there's Ethereum blockchain. And there's, I guess, the application frameworks like BlockApps, Strato, R3 Corda, Hyperledger Fabric, and Chain. So we packaged all of those solutions up and basically put them in the cloud for you to use. All right? And the idea behind us doing this in this first iteration of blockchain as a service is we want to test out how well do those solutions hold up. What do customers use? Are they actually taking advantage of the smart contracts capabilities? If so, how? So we want to fail fast and cheap. We want to be able to mix and match blockchain technologies, create and innovate, share solutions, and just really kind of learn from this exercise of what do our customers really want. So to that, I guess on that note, we created a set of marketplace offerings. And this is, if you guys haven't seen kind of like the Azure Portal or Azure Marketplace Portal, in the marketplace, it's sort of like an app store for cloud apps. So there's plenty of different applications you can find. If you go to azure.com/marketplace, it's not just blockchain. Blockchain is just a small piece of it. We enable ISVs in machine learning, AI, DevOps spaces, big data vendors. You can find many, many solutions there and easily deploy them into your cloud infrastructure. But in this talk, we're really interested in the marketplace offerings for blockchain. So the easiest way for us to explore what's available in Azure is to go to portal.azure.com. This is the Azure portal. And we want to create a new solution. And here, I'll just specify blockchain and just see what kind of solutions are available for me to use. So I'm not sure if it's visible. Let's just enlarge this. Yeah, this is visible. So you can see this Emercoin blockchain engine, Ethereum consortium blockchain, Strato blockchain multi-node, so DevTest Labs, Quorum. So all of those different variations of blockchains that you can basically deploy and have what we call a private or enterprise blockchain stood up in your subscription. So let's just take a look at the Ethereum consortium blockchain. All right, and if you read through this, you will see that basically it's going to create a private blockchain for you, but actually it's a multi-node blockchain enabling multiple people to join in. All right, so after you fill out this basic information, I'm not going to do it just because in the interest of time, and I have already done this. You fill in this basic information with credentialing for the client and the infrastructure size that you want to use. You will have a fully functional private blockchain inside your subscription that you can actually interact with. All right, and I will go ahead and demonstrate this shortly right after this slide because I think it's pretty important. This next slide that actually talks about differences in blockchain solutions. Let's take a look at that. So as you saw in the Azure Marketplace, we're trying to play Switzerland. We're enabling everybody. So, and here on this slide, I actually borrowed from the Medium post here and give credit properly. So let's just take a look why you would want to choose one or the other. Let's say the blockchains that exist out there. And so, for instance, the Ethereum is a very popular one, and we work with the guys behind this platform very closely. So then there's Hyperledger Fabric, which some of our competitors actually really kind of are really pushing forward and innovating on. And so an R3 Corda, that's probably three of the most popular blockchain frameworks out there today. And so what you have is different mode of governance. So for Ethereum, you have Ethereum developers, which is exactly what's sort of attractive to us. So Ethereum is actually, it's very popular. It's basically a very popular public blockchain. If you guys are following Ether, I guess I was just I was just telling my wife, like, last year, I went to a consensus conference in New York City. It was about $6. Today I checked, it's about 307. So one Ether, I guess, is having a moment. But because there are a lot of developers are developing against the public Ethereum blockchain, we also want to enable in our private, our enterprise blockchain and leverage that knowledge. So however, kind of like, in contrast to that, you have basically Hyperledger Fabric, which is a relatively closed permission, I guess, or specifically private blockchain only. As you can see, sort of like in mode of operation, Ethereum can be either public or private. Hyperledger Fabric is just private. R3 Core is private as well. And so the different modes of reaching consensus, right? And so again, consensus is just basically the mechanism by which nodes in the network kind of agree which blocks should become a part of the chain. So the initial one was all proof of work, which is cryptographic puzzles, puzzle solving. Think Bitcoin. This is exactly what it does. LDSO's massive data centers, both in China and in Russia, are structured around mining. So proof of work. And actually, Ethereum has slowly started migrating towards what they call as proof of stake, where basically the node that approves the transactions is randomly selected based on the stake that they have in the network. So I believe it's kind of like I was reading about it. I believe the way they do it is just like every 100th transaction is basically using proof of stake mechanism as opposed to proof of work. So, but anyway, so I guess, so that's Ethereum. In Hyperledger Fabric, there's multiple approaches. And then I guess it's the same thing in Corda. You can see that you can write smart contracts in different languages. Ethereum uses this language called Solidity, which looks very similar to JavaScript, and we'll take a look at that shortly. In Hyperledger Fabric, you could basically write your contracts in Go or Java, but I also believe there's a specific studio that kind of allows, IBM has built a specific kind of a interface that allows you to have a more visual or more JavaScript-like approach to development. And so same thing for Corda, Java, and then currency. This is an important thing here, right? So if we think about public blockchain, there's going to be some kind of currency involved, because otherwise, how do you sort of motivate the node to keep working, right? They're not going to work for free. Somebody needs to get paid. So, so in Ethereum, you have Ether, and you also get paid basically. Every transaction has a little tax on it called gas, I guess, and this gas is being charged and basically refunded back to the approving node. In a sense, so think about like to execute a transaction or to submit your contract or execute a transaction on the Ethereum blockchain, you have to pay a little bit. So that's how the currency works in Ethereum. But so for private blockchains like Hyperledger Fabric and R3 Corda, you don't really have a currency because you don't need it, right? If it's a private blockchain that you have either agreed to run within your own organization or consortium organizations, I mean, basically nobody needs to stay motivated by some kind of monetary means because they're already motivated by their boss to do this. All right, so now this is code camp, so we absolutely must write code, all right? So as I kind of showed you in the previous kind of marketplace, I guess, walkthrough, this is the way you deploy Ethereum consortium blockchain. I have already done this. And so if I look on my dashboard, it's fine. This is kind of what it looks like. And if you guys are familiar with Azure Portal, you can see that they deploy a whole bunch of resources. So like several virtual machines, several storage accounts, et cetera. So kind of our team built these templates to actually deploy this infrastructure into Azure, so you don't have to worry about that. This is kind of like a key thing here. And I will show you shortly where all of this stuff is documented, so you don't have to dig for it. And it's actually as part of the slides as well. So as part of the deployment mechanism, we have the ability to output certain parameters. So once the deployment finishes in the Azure Portal, you can see that the admin side for this Ethereum consortium blockchain is at this URL. So I'm going to go ahead and just paste this URL. And this is basically, it says, hey, I guess your private blockchain is ready to rock. All right? So how do we interact with this? And then we interact with this. Here's the walkthrough that I mentioned. It's part of the slides, basically saying Ethereum consortium network deployment made easy. So the part of the interaction is you have to create, I guess, wallets on the Ethereum blockchain, and then use this simple mechanism to basically send yourself 1,000 Ether or send somebody else 1,000 Ether. So I have already created 2 wallets. So I'm using this Chrome plugin called, here's what it's called. So it's MetaMask version 3.10. So I created 2 accounts for myself and my wife. So Mariana, and let's see, I'll switch account to Eugene. So the best way, or one of the best ways to make your wife happy is to send her 1,000 Ether, right? Because as I mentioned, it's $300 per Ether, so 300 times 1,000, that's 300,000, right there. Well, that's a good question. So that's my next point. So the best way to make her happy is to send her 1,000 Ether. The worst way, well, actually, the best way to make her upset is to tell her this is private Ethereum blockchain. This is not public. So basically, so whatever you do here is only localized to your instances on Azure. So obviously, this Ether is worthless, right? However, you know, she can be happy for a few minutes. So let's just kind of interact with this. So use MetaMask. I'll switch account to my wife. Just get her basically copy address to the clipboard. Paste this address here. And let's just note kind of like the balance. Her balance is $18.99. Let's just send her 1,000 Ether. All right. So in about 10 seconds, we should see this balance change to $28.99, just because obviously this is sort of like we're posting transactions to the ledger, and then it takes about 7 to 10 seconds to kind of get through this. So yeah, $28.99. All right. So we know our blockchain is functioning, or at least just like passes the basic test. So what can we do next, right? Well, the next thing I told you to do, well, I mentioned that you can do is just you can deploy, you can give this thing intelligence, right? You can deploy smart contracts on top of it. And so this walkthrough actually talks about exactly how to do this. In this walkthrough, you can get all the details about the parameters, the MetaMask plugin, the architecture, etc. But what I really want to focus here is just a smart contract guide. So if you navigate here, and I'll open a new tab, I already have a couple of smart contracts, one that comes by default, deployed on here. And I'll kind of zoom into this because this is pretty important, right? So this is Solidity. It looks very JavaScript-like. So you can see the definition, contract stakeholder. This is the very, very basic contract that says, hey, just change those values. Change open number, change open string, and change my string. So all it does is you can see some parameters come in, and we basically adjust those values on the state, on this basically state that this contract maintains on the blockchain, and just basically it keeps track of those values. Right? So this is, if you're a JavaScript developer, you will probably feel right at home authoring this. The one thing that I wanted to point out here, which is pretty important here, is this modifier. So it says only owner. So modifier only owner is being applied to this function right here, function change my string. So there's a modifier only owner that says nobody but the owner can change the string. All right? So basically, if they try to change this, they will get an error. All right, so let's just go ahead and create this. So kind of like the plugin and this framework, they work together to deploy these contracts on the blockchain. As you can see, this gas price right here that I mentioned, it's probably not very visible, but basically it's 94, it's 0.009 Ether. So this is how much it will take me to actually submit this transaction to a blockchain. That's fine, I have enough money, or Marianne has enough money or enough Ether in her account to deploy this. So as you can see, the creation of the smart contract we're deploying is pending. Shortly we will see it basically being deployed. And now your applications can start interacting with this smart contract. In a very simple, this is obviously a very simple thing. All it does is just changes the numbers. Or state-based, sorry. So okay, so let's recap. So and actually, I know it can get confusing here, but you know, in contrast to Bitcoin, the way you make money, or the way you make actually money on the Ethereum blockchain, yeah. Right. So basically, all right. Let's talk about proof of work first. Proof of work is basically a cryptographic puzzle that is automatically adjusted for on Bitcoin blockchain to be kind of resolved in according to the computational power available in the network within about 10 minutes. So basically, the more nodes join the network, the harder the puzzle becomes. But it's really pretty much random guessing in a sense. It's sort of like you guess some sort of a number, and basically then you see, okay, did this guess happen properly, or I guess the Bitcoin verifies, is this the appropriate guess? So somebody eventually, within 10 minutes, guesses it appropriately. So basically, think about it, you know, massive computers at the data centers performing all this kind of guesswork in a sense, and that's proof of work. They're working very hard at it, right? So proof of stake does not take nearly as much computing power at all. Proof of stake says we will randomly select the node that will actually write these transactions to the blockchain based on the stake that they have basically on the system. Sort of like, yeah, so if your node, the submitting node. So let's say you've been selected or randomly selected. Okay, how much stake do you have in this network? Are you a fairly large stakeholder? Which you can clearly see none of those systems are perfect, right? Proof of work has its own deficiencies. I mean, certainly you don't want somebody's already built in like all those data centers in Russia and China, right? And they can clearly, if they wanted to kind of partner together, perhaps overwhelm the network and kind of introduce all kinds of inconsistencies. And the proof of stake is in a similar manner, right? However, sort of like when you get away from the public blockchain, right, and talk about the enterprise, or I guess let's say permission blockchain, we also call them. So in other words, you control who joins the network. Then things become different, and clearly you don't need proof of work anymore, right? If you trust the participants or have partial trust in the participants. Anyway, so hopefully that kind of makes sense. All right. So we can see that the smart contract got deployed here, and here. Not here. Here we can actually interact with this even from this interface directly. So for instance, if I wanted to change this number to be 5, I would just click this. It says, okay, you have to pay for gas. I say, okay. So basically, I submit my transaction to network. Clearly, in the real world, you wouldn't do this. Your distributed application would do it with some sort of a RESTful interface. But that's the basic idea. So all of this tooling is available to you. Oh my God, I'm running out of time here. So all this tooling is available for you to try on your own in Azure today, in addition to other tools out there. So, but just to give you an idea of obviously how the smart contract can be much more complicated than just the basic change of state, is this escrow contract. And the basic, if you guys, if you're buying a house, you know that basically the standard escrow contract is, you know, there's certain money that gets put aside in the escrow until both transactions are kind of like, until the buyer obviously proves that they have enough money and seller says, here's a house. So there's like a holding period. So the smart contract, or in a very loosely form, it can ensure that basically the middlemen are taken out of the picture. And so if all the parties on the blockchain are interacting with the blockchain itself, then in theory, you don't need middlemen in the form of companies that kind of process this. And clearly, you can save thousands of dollars. So that's sort of like, that's kind of like the golden spot right there, right? So all of a sudden, you know, if we could if we could bring everybody to the same table and make them work on this thing together, or all of us work together, we can certainly enable many more scenarios than are available to us today. And probably this could potentially happen with a shared database, but the likelihood is very, very low. All right, so, okay, let's get back to the slides here. And I only have 5 minutes. But anyway, let's talk about developer workflow. So you saw me just kind of running basic experiments in the browser, and that's great, that works. But probably in the real world, if you wanted to actually author blockchain applications, this is not how you would normally work, right? most likely you will create an application and then basically deploy this application, or we call it decentralized app. But hopefully it's clear what I mean by decentralized app. They also call it DApps. So it's basically, think about it, it's a smart contract with kind of like user interface on top of it. So we basically deploy it and it just like works with blockchain as a backend. So what kind of tooling do we have today in Azure to kind of help you with this development? So there's BlockApps. So if you go to Azure, the same portal I showed you, azure.com/blockchain, you will see that the BlockApps has a solution in there that enables you to actually fast track this development. So you have the Strato blockchain at the bottom, which I believe is basically a fork of Ethereum, or even just very close to Ethereum itself. And so on top of that, you have the user interface, like a management console. You can see which smart contracts are executing, the state of the network. So in other words, it's kind of like it's a more visual development, and it's available to you today in Azure. So the same with Truffle. This is more of a command line tooling, but it's probably the most common tool used to actually push and test smart contracts on Ethereum blockchain. So you have the testnet, you have Ethereum JS test RPC, which I believe is just basically like an in-memory copy of Ethereum blockchain that kind of allows you to really debug your work or get quick tests out of the way. So there's a Truffle SDK, and again, just the command line tooling with Geth Web3 and CLI. I believe Geth has been renamed to CPD++. So this is just a side note. This is not really that important. We're saying we're going to release Project Lexington, which will be kind of like a POC framework, tying every single concept that we talk about the enterprise blockchain together, and it will be just basically sample applications, kind of like Northwind traders, so to speak, if you guys are familiar with that, for blockchain, and it's coming out shortly. So let me just talk about, for the next 3 minutes, let me just talk about kind of like where we see this going, or where we want to be, in a sense. So today we have all those solutions. We work with startups closely. Where we really want to be is in the blockchain 3.0. It's basically cloud servicing, multi-layer middleware, plus Criplets. So what does that mean, right? So here's sort of, actually I'll skip through those slides. Here's what it means from our point of view, in a sense. So today, blockchain has some missing parts. Even with 2.0 Ethereum-based or smart contracts-based blockchains, they're slow, they're insecure, the management tools are lacking, and basically there's opportunity for us to actually do better. So this is exactly where we want to go next, or where we are going next. So we are, and the central to this concept, or central to the strategy is the concept called Criplets. And it may be not a very fortunately named entity, so to speak, but the idea is to take advantage of the Intel SGX architecture, which allows you to sort of safeguard your code in an unknown environment. All right, so if you think about it, kind of like it's the reverse of like a phone framework, where you basically have a trusted environment, but an untrusted app being executed. So you sandbox it. So this is the inverse of that. So let's say we want to be able to execute code in the untrusted environment, but the code that we trust. So you kind of invert the equation there, and the SGX architecture, Intel, I guess, SGX extensions enabled through Skylark architecture, I get too many buzzwords, but enables you to actually guarantee that. So it enables you to create those guarantees that allow the secure and actually very performant execution of trusted code in an untrusted environment. So basically, if you are deploying the code that you built, you know it's your code, you trust that you're able to verify their hash signature that it is indeed your code, you can run it anywhere where those extensions are enabled. So we want to secure this, we want to introduce those Criplets to enable the secure communication, because today, inherently, if you call out into the open space or to the third-party applications from smart contracts, it's inherently insecure, because how can you guarantee that the entity on the receiving and responding end is really legitimate and is not actually trying to subvert the system? So the Criplets is really key to enabling the servicing of blockchain 3.0. And this is kind of like a complicated diagram of what we're actually sort of trying to achieve. But we're trying to be very independent in terms of the blockchains that we talk to. Corda, Ethereum, Chain, basically, we want to enable all of those blockchains to actually use our Criplet service. And then on the other hand, we want to enable developers, all of the .NET developers out there, Java developers, F# developers. We want to enable them to write those Criplets and then perhaps actually even sell them on the marketplace, so to speak. Criplets that would provide services to blockchain applications. And so the key enablers there are basically Criplet Fabric, Criplet Container Service. So those would enable kind of the communication between the applications running not necessarily on the chain, on the blockchain itself, but outside of that, but yet guaranteeing the secure execution environment. Yeah?
Does that mean that the blockchain environment will be portable between the different blockchain environments?
No, well, I don't think so. In the sense, like, kind of like we are going to basically try to talk to them all. So in other words, how portable is it at that point? I mean, you probably couldn't just copy and paste from one blockchain to another, but perhaps you could use our framework to actually talk between them. So portable in that sense of interoperable is probably the better word.
So what I mean is, like, if I write a Criplet for one blockchain,
Anybody should be able to call it into it. Yep.
will I be able to run it on
Yeah, because technically you will not be running on the blockchain itself. We want to basically isolate, but guarantee the secure execution environment at the same time. Because again, kind of like we feel like the execution environment of blockchain is slow. And then also the additional optimization we want to build is obviously right now, if you deploy a smart contract onto a blockchain, every node in the blockchain executes that. Clearly the optimization there could be just one node should be able to execute that. Of course, that would change kind of like, that would require some changes to the framework. So, but I think yes. So you should be, our vision is that your Criplet should be able to talk to any of those. Like a PaaS for blockchain? Like a platform as a service? That's a good analogy, certainly. So we call it, so the whole project calls, and this, we're famous for confusing this too. So there's multiple names. Blockchain as a service, also known as project codename Bletchley. So yeah, but blockchain as a service is the one I would probably stick with going forward. So I just kind of like wanted to probably briefly mention, I know I'm out of time here, but in a sense, we're already making incremental movements towards blockchain 3.0, right? While we kind of basically drag our feet a little bit, other guys have come in and said, hey, we're going to do a portion of this. So this Enterprise Ethereum Alliance was formed, and Microsoft is a member, along with, I think, with like 150 other companies, including Indian government, JP Morgan Chase, some major players, MasterCard, I believe, too. So they're saying, hey, we're going to, in the Enterprise Ethereum Alliance, we're going to figure out how to make both a public and enterprise or private blockchains run together. And so the work is just kind of like evolving. But what did come out of this Enterprise Alliance, or specifically JP Morgan in particular, is this blockchain called Quorum. So here they said, we want a blockchain specifically for financial institutions. And financial institutions have some key requirements that have to be met, such as privacy. We have to enable alternative consensus mechanism, to your point. So peer permissioning and we need basically to be performant. So JP Morgan actually released this as open source. You can run this today, and it works. And so what they do is really tricky there in a sense. So basically, they maintain two separate states, or state, I guess, databases. I shouldn't say database, not database. So basically, two separate states. There's public state, and there's a private state. And so the private state, only certain, I guess, participants can peek into. And the public state is sort of like open to everybody. So, and it works for financial institutions, I guess. And what they did is they forked Ethereum, actually. So it's a slight modification, I believe, that they made. So, and I guess a lot of people are actually doing that. They say, okay, Ethereum works great for, let's say, public blockchains, and in many cases for enterprise blockchains, but it doesn't work so great for our use cases. So we're going to fork it. We're going to introduce those, I guess, the separation of states, and introduce additional, basically, consensus mechanism, which kind of like, check this out, right? The majority voting consensus. Basically, there's no proof of work. This is not proof of stake. It just says, hey, let's like, everybody raise their hands who thinks this transaction should go in. Okay, great, let's go it in. So I mean, you can see how in the public blockchain, this mechanism will totally falter because it's so easily spoofed. And then also, I guess, the raft-based consensus, and I believe what this is just like a leader election. So the guy who is a leader, or the node, just says, I'm a leader, I'm going to make this, I'm basically decide whether this is going to go in or not. And then when the leader kind of falls down, like a candidate gets elected. So I believe that's how raft works. So introducing all this alternative consensus mechanisms will allow you to actually optimize the blockchain. So while at the same time preserving those key properties of it being still a secure, shared, distributed ledger. So that's sort of like, so you lose some of those things, right? Kind of like, you know, the public can no longer rely on this stuff, right? You cannot deploy this consensus mechanism and say, trust us, yet you retain some other properties that are very attractive and make people kind of interact with each other. So depending, I guess, on where you land with your opinion about enterprise blockchain, hopefully I was able to make some points of where it could make sense and just kind of like was able to kind of communicate where we're going with this. And where the other guys are going too. I mean, the JP Morgan guys just picked it up and said, we're just going to do this, and did this. And I guess before the end of the year, I'm sure we'll see a lot more of those developments. That's it. That's all I had, guys. Sure.
Is there a trial for your platform or something like that?
Certainly, yes. There's all the resources here. If you go to Azure.com, I believe it's a $300 trial. I'm not sure if you're an Azure customer now. If you're not, if this is the first time you sign up, it's a free account, $200 credit. So with this Azure credit, you can do anything on Azure, including deploying the blockchains and just, I guess, any solutions that you can think of in Azure. So yeah. All right, well, thanks for coming, guys.